Atlantis wasn't swallowed by the sea, it bled into the Nile. That's not poetry, that's a hypothesis. And tonight, we're going to put it through the ringer. For decades, we've treated Atlantis like a fairy tale. Lost continent, swallowed by waves, end of story. But what if we've been looking in the wrong bloody place? What if the greatest mystery of the ancient world isn't underwater? What if it's been staring us in the face from space? A massive bullseye carved into the Sahara Desert. Tonight, we're auditing one of the most controversial claims in alternative history, that survivors of Atlantis became the founding fathers of Egyptian civilization. Here's what we know for certain. Egypt exploded onto the historical stage with impossible sophistication. Massive pyramids, precise astronomy, complex mathematics, all appearing with shocking suddenness around 3100 BC. Mainstream archaeology says they figured it out from scratch. But what if they had help? What if they inherited blueprints from a civilization that vanished overnight? Let's start with the only bloody source we have for Atlantis, Plato, and right off the bat, we've got a problem. Around 360 BCE, this Greek philosopher drops two dialogues, Timaeus and Critias, that contain the most detailed description of a lost civilization ever written. But he claims he didn't make it up. According to Plato, the story came from Solon, the great Athenian lawgiver, who heard it from Egyptian priests at Sais around 590 BCE. These priests told Solon that their records went back 9,000 years, to a time when Athens fought a war against a mighty island empire called Atlantis. Now, mainstream scholars have been dismissing this as pure allegory for centuries. They argue Plato invented Atlantis as a cautionary tale about hubris and imperial overreach. Athens gets too big for its boots, takes on a maritime empire, and both civilizations destroy each other. Nice moral lesson, completely fictional. But here's where it gets interesting. If Plato was just spinning a yarn, why did he include such incredibly specific details? We're not talking about vague mythological descriptions here. We're talking about urban planning blueprints. Listen to this description from the Kriatos. The island was larger than Libya and Asia put together. That's roughly 4 million square kilometers. Massive, but not impossibly so. It was situated in front of the Pillars of Hercules. That's the Strait of Gibraltar. The whole country was very high and precipitous on the side of the sea, but the central plain was smooth and even. But it's the capital city description that'll make your jaw drop. Plato describes a city built in concentric circles, 3 rings of water separated by 2 rings of land. The outer ring of water was 3 stadia wide, the inner ring 2 stadia, the central island was 5 stadia in diameter. That's roughly 550 meters across for the central island, with rings extending outward to about 1,850 meters total diameter. The city was connected to the sea by a canal, 3 plethrons wide, about 90 meters, and 50 stadia long, roughly 9 kilometers. The palace and temple complex sat on the central island. The temple of Poseidon was covered in silver, with pinnacles of gold. The palace was surrounded by a wall covered in brass, tin, and orichalcum, a mysterious reddish metal that hasn't been definitively identified. Plato describes the island's geography in detail. Mountains to the north, protecting the central plain from cold winds. The plain itself was rectangular, about 3,000 by 2,000 stadia, roughly 555 by 370 kilometers. Rivers flowed down from the mountains, providing fresh water and fertile soil. The level of detail continues. He describes the island's military: 10,000 chariots, 120,000 hoplites, 60,000 light infantry, 60,000 archers and slingers. The naval force included 1,200 ships. The island was divided into 10 kingdoms, each ruled by a descendant of Poseidon. Now, here's what's absolutely crucial about Plato's timeline. He doesn't just say Atlantis existed long ago. He gives us specific dates. According to the Egyptian priests, Atlantis was destroyed 9,000 years before Solon's visit to Egypt. That puts the destruction around 9,600 BCE, right at the end of the last ice age, during a period of massive climate change. This timing is significant for several reasons. First, it coincides with the Younger Dryas period, a sudden return to Ice Age conditions that lasted about 1,300 years. Second, it's right around the time that global sea levels rose dramatically as ice sheets melted. Third, it's when we see the emergence of agriculture and the first permanent settlements in the archaeological record. But here's the kicker. Plato claims Atlantis wasn't destroyed by normal warfare or gradual decline. It was wiped out in a single day and night by earthquakes and floods. In one day and one fatal night, all your warlike men in a body sank into the earth, and the island of Atlantis, in like manner, disappeared and was sunk beneath the sea. The mainstream archaeological position is clear. There's no independent corroboration for Plato's account. No other ancient source mentions Atlantis. No Egyptian records discovered by modern archaeology confirm the story. The consensus is that Plato created Atlantis as a literary device to explore themes of ideal society and political decay. But critics of the mainstream view point out some problems with this interpretation. First, Plato presents the story as historical fact, not allegory. In the Timaeus, he specifically states that the fact is not fiction, but true history. Second, the unfinished Critias suggests he intended to tell the complete story. Why start an elaborate hoax you can't finish? Third, the level of detail seems excessive for a simple moral tale. There's another intriguing detail. Plato describes the royal conferences of Atlantis, where the 10 kings would meet to discuss policy and settle disputes. These meetings followed specific rituals, involving the sacrifice of bulls and the mixing of their blood with wine in a golden bowl. The kings would then vote on matters of state using golden tablets. If you're finding this as fascinating as I am, give this video a thumbs up. It really helps with the algorithm, and it lets me know you want more deep dives like this. The description of Atlantean society is remarkably detailed. Plato describes their agricultural system. They grew 2 crops per year thanks to their irrigation system. He details their architecture, buildings faced with brass, tin, and orichalcum. He describes their harbors, filled with triremes and merchants from around the world. But perhaps most intriguingly, Plato describes their gradual corruption. Initially, the Atlanteans were noble and virtuous, close to their divine ancestry. But over generations, the human nature got the upper hand. They became aggressive, greedy, and warlike. This moral decline supposedly triggered the gods' decision to destroy them. So we're left with a puzzle. Either Plato created the most detailed fictional civilization in ancient literature as a philosophical thought experiment, or he was recording, however inaccurately, some kind of historical memory. The question that's haunted scholars for over 2 millennia is simple. Which interpretation fits the evidence better? Here's what we can say for certain. Plato's description is too specific to dismiss without investigation. The geographical details, the urban planning, the timeline, they're all testable hypotheses. And that's exactly what we're going to do. We're going to take Plato's description and see if we can find anything in the archaeological and geological record that matches. Right? Let's talk about the most mind-blowing geological formation on Earth. Deep in the Sahara Desert of Mauritania. There's something that shouldn't exist. From ground level, it's just rocky ridges and salt flats. But from space, it's a perfect bullseye, 40 kilometers across, etched into the heart of Africa. They call it the Richite structure, but locals know it better as the Eye of the Sahara. And when you see it from orbit, you'll understand why. It looks like a massive eye staring up at the cosmos, with concentric rings of different colored rock creating the iris and pupil. The structure was first photographed from space during the Gemini missions in the 1960s. Astronauts used it as a landmark because it's so bloody distinctive. But it wasn't until high-resolution satellite imagery became available that researchers could study its true complexity. Here's what we see from above. Multiple concentric rings of different colored sedimentary rocks. The outermost ring is about 40 kilometers in diameter. Moving inward, we have distinct bands of different geological formations, sandstones, limestones, quartzites, and volcanic rocks. The center contains a roughly circular depression filled with more recent sediments. Now, let's talk about the immediate geographical context, because this is where things get really interesting. To the north of the Richite structure, we have the Adra Plateau, a mountainous highland that forms a natural barrier. To the south, the land opens into a vast plain that stretches toward the Atlantic Ocean. The geological mainstream has a straightforward explanation for the Richite structure. They classify it as a deeply eroded geological dome. About 100 million years ago, tectonic forces pushed a section of the Earth's crust upward, creating a dome-shaped uplift. Over millions of years, erosion wore away the softer rocks, leaving the harder layers as concentric rings. This process, called differential erosion, is well understood. Different rock types have different resistance to weathering. Harder rocks, like quartzite, stand up to erosion better than softer rocks, like limestone or sandstone. When a dome erodes, you get these beautiful concentric patterns as the geological layers are exposed. The color variation comes from the different mineral compositions of each rock layer. Iron oxides create reddish hues, organic materials create darker colors, and different crystal structures create everything from bright white to deep black. It's essentially a geological rainbow preserved in stone. Here's where the standard geological explanation starts to get a bit wobbly. First problem, the Richite structure is remarkably circular. Natural erosion patterns tend to be irregular, following the path of least resistance. Perfect circles are rare in nature, especially at this scale. Second problem, the structure sits in the middle of a relatively flat plain. Geological domes usually form along tectonic plate boundaries or over volcanic hotspots. The Richite structure is hundreds of kilometers from the nearest active tectonic zone. Third problem, there's evidence of hydrothermal alteration throughout the structure. That means hot, mineral-rich water flowed through the rock at some point, altering its chemical composition. This kind of alteration is more commonly associated with impact craters than with simple erosional features. Some geologists have proposed that the Richite structure is actually an impact crater, the result of a massive asteroid or comet strike. The circular shape, the size, the hydrothermal alteration, the concentric ring structure, they all fit with what we see at confirmed impact sites. The impact crater hypothesis gained credibility when researchers found evidence of shocked minerals within the structure. Shocked minerals are crystals that have been subjected to pressures and temperatures that can only be created by massive impacts or explosions. You find them at nuclear test sites, asteroid impact craters, and areas of intensive mining with explosives. But here's the thing about the impact hypothesis, it doesn't fully explain all the features we observe. Most impact craters are much deeper than the Richat structure. They also typically have a central uplift, where the compressed rock rebounds after impact. The Richat structure has a depression at its center, not an uplift. There's a third possibility that mainstream science hasn't seriously considered: artificial construction. Now, before you roll your eyes, hear me out. I'm not talking about ancient aliens or lost super technology. I'm talking about the possibility that an ancient civilization modified a natural geological formation. Think about it this way. If you were going to build a massive ringed city, would you start from scratch on flat ground, or would you find a natural formation that already had the basic structure you needed? The Richat structure would have been an ideal foundation for a ringed city. Now, let's examine the rock types found in the Richat structure, because this is where Plato's account gets eerily specific. He describes the buildings of Atlantis as being faced with 3 different types of stone: black, white, and red. In the Richat structure, we find exactly these color variations. The outer rings contain dark-colored volcanic rocks and iron-rich sediments that weather 2 deep black and brown. The middle rings contain lighter-colored quartzites and sandstones that appear bright white in satellite imagery. The inner areas contain iron oxide-rich rocks that weather 2 distinctive reddish colors. Plato specifically mentions that the Atlanteans used these different colored stones decoratively, alternating bands of black, white, and red stone in their construction. Look at the Richat structure from space. You see exactly this pattern. Alternating bands of black, white, and reddish rock in concentric circles. Let's talk about size and scale. Plato described the overall diameter of the Atlantis capital as being about 127 stadia, which translates to roughly 23 kilometers. The main ring structure of the Richat is about 25 kilometers in diameter. That's not just close, that's spot on. The proportions of the rings also match remarkably well. Plato described the central island as being 5 stadia, across about 900 meters, surrounded by the first ring of water at 1 stadium wide, about 180 meters. Then a land ring 2 stadia wide, about 360 meters. Then another water ring 2 stadia wide. Then the final land ring 3 stadia wide, about 540 meters. When you overlay these proportions on the Richat structure, the correspondence is striking. The central depression is roughly the right size for Plato's central island. The ring widths match the proportional relationships he described. But here's where we need to be careful about confirmation bias. The human brain is incredibly good at finding patterns, even when they don't exist. We see faces in clouds, religious figures in toast, and conspiracy in coincidence. The fact that the Richat structure resembles Plato's description could be just that, a resemblance. Let's examine the broader geographical context, because this is another area where the correspondence gets interesting. Plato said Atlantis was in front of the Pillars of Hercules, the Strait of Gibraltar. The Richat structure is roughly 500 kilometers south of the Moroccan coast, well within the Atlantic drainage basin. Plato described a rectangular plain stretching south from the mountains, about 3,000 by 2,000 stadia in size, roughly 555 by 370 kilometers. South of the Richat structure, there's exactly such a plain, bounded by the Senegal River to the south and extending west toward the Atlantic. The northern mountains Plato described. The Adra Plateau rises immediately north of the Richat structure, creating a natural windbreak just as Plato described. The central position of the ringed city in relation to the plain. The Richat sits almost exactly where you'd expect, based on Plato's geographical description. Now, here's the million-dollar question. Could this area have been accessible to ancient ships? Today, the Richat structure sits about 400 kilometers inland from the Atlantic coast. But 12,000 years ago, during the end of the last ice age, conditions were very different. During the last ice age, sea levels were about 120 meters lower than today. But as the ice sheets melted, sea levels rose rapidly, in some periods as much as several meters per century. At the same time, North Africa was experiencing what's called the African humid period, a time when the Sahara was green, filled with lakes, rivers, and abundant wildlife. Geological evidence shows that major rivers once flowed through what is now the Sahara Desert. Satellite imagery and ground-penetrating radar have revealed ancient river channels, some of which connect the Richat region to the Atlantic Ocean. These channels were active during the early Holocene, roughly 12,000 to 6,000 years ago. There's also evidence of ancient lakes in the region. Salt deposits, lacustrine sediments, and fossil shorelines indicate that much of the area around the Richat structure was periodically flooded by freshwater lakes. Some researchers have suggested that these lakes could have been deep enough and large enough to support significant water transport. But could seawater have reached the Richat structure? This is where the analysis gets complex. Even with higher sea levels and different river patterns, the elevation of the Richat structure, about 400 meters above current sea level, makes direct marine access unlikely. However, there's another possibility: catastrophic flooding. If you've been following recent research into the Younger Dryas impact hypothesis, you'll know that some scientists propose that a cosmic impact, or airburst, around 12,900 years ago triggered massive flooding, climate change, and the extinction of megafauna across North America and potentially other continents. Could a similar impact or series of impacts have affected North Africa? There's some intriguing evidence to consider. The Richat structure itself shows signs of hydrothermal alteration that could be consistent with impact-related heating. There are also numerous smaller circular structures scattered across the Sahara that some researchers interpret as impact craters. If a major impact occurred in the Atlantic Ocean off the coast of Africa, it could have generated massive tsunamis that penetrated far inland through the river systems. Such flooding could have temporarily connected the Richat region to the Atlantic, exactly as Plato's account suggests. The timing would fit with Plato's account of sudden destruction. Atlantis wasn't gradually abandoned or slowly conquered. It was destroyed in one day and one fatal night by earthquakes and floods. A cosmic impact could explain both the seismic activity and the catastrophic flooding. But, again, we need to be careful about building castles in the air. The impact flooding scenario is speculative. We need hard evidence, geological, archaeological, or both, to support these possibilities. Let's talk about what we should expect to find if the Richat structure really is the remains of Atlantis. First, we'd expect archaeological evidence: tool fragments, pottery sherds, building stones, human remains. The harsh desert environment would actually be excellent for preservation, much better than underwater sites. Second, we'd expect evidence of artificial modification of the natural ring structure. Quarry marks, dressed stone blocks, foundation patterns, engineered water channels. Ancient civilizations left traces of their construction activities that are recognizable even after thousands of years. Third, we'd expect dating evidence that corresponds to Plato's timeline. Radiocarbon dates from organic materials, thermoluminescence dates from pottery or heated stones, optically stimulated luminescence dates from quartz grains in construction sand. Fourth, we'd expect evidence of the catastrophic destruction Plato described. Impact materials, tsunami deposits, widespread burning, sudden abandonment rather than gradual decline. So far, systematic archaeological investigation of the Richat structure has been limited. The remote location, harsh environment, and political instability in the region have made comprehensive surveys difficult. But the surveys that have been conducted have found stone tools consistent with Neolithic occupation, roughly 6,000 to 4,000 years ago. That's significant because it shows the area was inhabited by humans during the period when the Sahara was still relatively green and habitable. But it's also problematic because it's several thousand years later than Plato's timeline for Atlantis. The lack of obvious architectural remains at the Richat structure is the biggest challenge to the Atlantis hypothesis. If this was once a major city with hundreds of thousands of inhabitants, where are the buildings? Where are the walls? Where are the harbors Plato described? Proponents of the theory argue that 12,000 years of erosion, sandstorms, and geological activity could have buried or destroyed most surface evidence. They point out that even much younger archaeological sites in desert environments can be completely buried by sand dunes and wind-blown sediments. They also argue that the ringed structure itself is the evidence, that the natural geological formation was modified and enhanced by human engineering, with the organic materials and softer building stones eroding away while the underlying geological structure remained. Skeptics counter that major stone construction should leave recognizable traces even after 12,000 years. They point to other ancient sites in North Africa, like the temples at Abu Simbel or the pyramids of Meroe, that have survived for thousands of years in desert conditions. The debate ultimately comes down to this. Is the correspondence between the Richat structure and Plato's description of Atlantis strong enough to justify the massive archaeological investigation that would be needed to settle the question definitively? Now we turn our attention east to the land of the pharaohs, where one of history's greatest mysteries unfolds along the banks of the Nile. Egypt didn't gradually stumble into greatness. It exploded onto the world stage with a level of sophistication that still makes archaeologists scratch their heads. Around 3100 BCE, something extraordinary happened. Within the span of just a few centuries, Egypt transformed from scattered Neolithic farming communities into the world's first unified nation-state. They developed hieroglyphic writing, monumental architecture, complex administrative systems, advanced mathematics, and astronomical knowledge that wouldn't be matched again for thousands of years. I want you to picture this timeline in your head. 3500 BCE, simple farming villages along the Nile. 3100 BCE, unified kingdom with complex writing, massive monuments, and sophisticated knowledge of astronomy and mathematics. That's 400 years to go from Stone Age to Bronze Age mastery. How is that even possible? Mainstream Egyptology explains this rapid development through a combination of environmental pressures and cultural innovation. As the Sahara dried out during the Neolithic subpluvial period, populations concentrated along the Nile Valley. This concentration led to competition for resources, which drove social stratification, technological innovation, and eventually political unification. It's a reasonable explanation, and there's archaeological evidence to support it. We can trace the gradual development of Egyptian culture through the pre-dynastic period, the Badarian culture around 4400 BCE, the Naqadar cultures from 4000 to 3100 BCE, showing increasing sophistication in pottery, metalworking, and social organization. But here's what bothers me about the conventional timeline. The knowledge explosion seems to happen all at once, not gradually. Take the Step Pyramid of Djoser, built around 2670 BC. It's not just the first pyramid, it's the first monumental stone building in human history. The architectural leap from mud brick mastabas to a 6-step pyramid 62 meters high is absolutely staggering. Look at the images on your screen. This is the step pyramid complex at Saqqara. Count the innovations you see. Cut stone masonry, complex internal chambers, sophisticated drainage systems, astronomical alignments, decorative columns, and a massive perimeter wall. How many generations of architects would it take to develop all these techniques? The architect responsible for the step pyramid was Imhotep, a man so revered that he was later deified. According to Egyptian records, he was not just an architect but also a physician, high priest, and sage. The Egyptians credited him with numerous innovations in medicine, architecture, and engineering. But here's the thing. Imhotep didn't leave behind any evidence of experimental structures or failed attempts. The step pyramid is architecturally sophisticated from the ground up. It's as if the Egyptians went from never building in stone to mastering monumental architecture overnight. The same pattern appears with Egyptian writing. Hieroglyphic script doesn't show the gradual development you'd expect from a newly invented writing system. The earliest hieroglyphs we've found are already sophisticated, with complex grammar rules, phonetic elements, and abstract concepts represented symbolically. Compare this to other early writing systems like Sumerian cuneiform or Chinese logographs, which show clear evolutionary development from simple pictographs to complex symbolic systems. Egyptian hieroglyphs seem to appear fully formed, with a complexity that suggests they were developed over centuries. But we don't have evidence of those centuries of development. Then there's Egyptian mathematics and astronomy. The Rind Papyrus, dating to around 1650 BCE, but copying material from around 2000 BCE, shows that the Egyptians had sophisticated mathematical knowledge, including fractions, algebra, and geometry. They could calculate the area of circles, the volume of cylinders, and the slope angles of pyramids. Their astronomical knowledge was even more impressive. The Great Pyramid of Giza, built around 2580 BCE, is aligned to true north with an accuracy of just 3/60th of a degree. That's a precision that wouldn't be matched again until the modern era. The pyramid's base perimeter relates to its height in the same ratio as a circle's circumference relates to its radius. The mathematical constant pi. Now, how do you acquire this level of mathematical and astronomical sophistication? It requires generations of careful observation, recording, and calculation. You need to track stellar movements across decades. You need to develop sophisticated surveying techniques. You need to understand complex mathematical relationships. The conventional explanation is that Egyptian mathematical and astronomical knowledge developed organically from practical needs. Farmers needed to predict the Nile's flood cycle, which required astronomical observation. Architects needed geometry for construction. Administrators needed mathematics for taxation and trade. This explanation works for basic mathematical concepts. But the level of sophistication we see in monuments like the Great Pyramid goes far beyond practical necessity. You don't need to encode pi in your architecture to build a stable structure. You don't need precision astronomical alignment to orient a building roughly north. There's something else that bothers me about the conventional timeline. The quality paradox. Egyptian architecture, art, and engineering reached their absolute peak during the Old Kingdom period. Roughly 2686 to 2181 BCE, the pyramids of Giza, built during the 4th dynasty, represent the pinnacle of Egyptian architectural achievement. But this creates a logical problem. Shouldn't we expect gradual improvement over time? Shouldn't later dynasties have built bigger, better, more precisely aligned pyramids? Instead, we see the opposite. Later, pyramid construction shows declining quality, less precision, and inferior engineering. Think about any technology you're familiar with: smartphones, cars, computers. Do they get worse over time, or better? The Egyptian pyramid timeline is like watching Apple go from the iPhone 14 back to the original iPhone over 1,000 years. It makes no sense from a technological development perspective. The Pyramid of Unas, built around 2375 BC, 2 centuries after the Great Pyramid, is smaller, less precisely built, and shows clear evidence of architectural decline. By the Middle Kingdom period, pyramid construction had largely ceased, and when it resumed in the New Kingdom, the quality was nowhere near the Old Kingdom standard. This pattern of early perfection, followed by decline, appears throughout Egyptian culture. The finest art, the most sophisticated literature, the most impressive monuments, they all date to the earliest periods of Egyptian civilization. It's as if the Egyptians started with complete knowledge and gradually forgot how to apply it. Now, this is where the Atlantis connection becomes intriguing. What if Egyptian civilization didn't develop in isolation? What if they inherited knowledge from an earlier, more advanced culture? What if the survivors of Plato's Atlantis carried their knowledge and expertise to the Nile Valley? This isn't a new idea. The ancient Egyptians themselves believed it. They called it Zep-Tepi, the first time, a golden age when the gods walked among men and established the foundations of Egyptian civilization. According to Egyptian mythology, the god Thoth gave them writing, mathematics, and astronomy. The god Ptah taught them architecture and engineering. Egyptian texts describe the Zep-Tepi as lasting 36,900 years, ending with the unification of Egypt under the first pharaoh. They claim that during this period, divine beings ruled Egypt and established all the customs, laws, and knowledge that defined Egyptian civilization. Mainstream Egyptology treats these accounts as religious mythology creation stories designed to legitimize pharaonic authority by connecting it to divine origins. But alternative researchers argue that mythology often contains kernels of historical truth, distorted by oral transmission over millennia. Consider the similarities between Egyptian and Atlantean culture, as described by Plato. Both were maritime civilizations with sophisticated knowledge of astronomy and mathematics. Both built in stone, using precise geometric principles. Both had complex religious systems centered on divine kingship. Both were ultimately destroyed by catastrophe. The architectural similarities are particularly striking. Plato describes Atlantean buildings faced with alternating bands of black, white, and red stone. Egyptian monuments frequently use this same color scheme: black granite, white limestone, and red sandstone arranged in decorative patterns. Plato describes the Temple of Poseidon in Atlantis as being covered in silver with pinnacles of gold. Egyptian temples were similarly decorated with precious metals, gold leaf on obelisks, silver inlays on temple walls, electrum caps on pyramid peaks. The religious parallels are equally intriguing. Both cultures worshipped gods associated with water Pison in Atlantis, Sobek and Hapi in Egypt. Both practiced bull sacrifice in important religious ceremonies. Both believed their rulers were descended from gods and possessed divine authority. Both cultures also show an obsession with astronomical cycles and calendar systems. The Atlanteans supposedly held religious gatherings every 5th and 6th year alternately. The Egyptians celebrated the said festival every 30 years, with additional celebrations tied to stellar cycles. But perhaps the most significant parallel is the emphasis on preserving knowledge for future generations. Plato describes Atlantean priests as keepers of ancient records. Egyptian priests served the same function, maintaining temple libraries and copying sacred texts across millennia. Now, let's address the elephant in the room. Where's the hard evidence for this connection? If Atlantean survivors really did establish Egyptian civilization, we should be able to find traces in the archaeological record. The problem is that direct evidence of knowledge transfer would be extremely difficult to identify archaeologically. Knowledge doesn't fossilize. Cultural transmission often leaves no physical trace. If Atlantean survivors arrived in Egypt with mathematical, astronomical, and architectural knowledge, but without distinctive artifacts or writing systems, their influence might be nearly invisible in the archaeological record. However, there are some intriguing anomalies in early Egyptian archaeology that could support the knowledge transfer hypothesis. First, there's the sudden appearance of sophisticated copper and bronze working techniques around 3100 BCE, without evidence of gradual technological development. Second, there's the mysterious appearance of cedar wood in early Egyptian construction. Cedar doesn't grow in Egypt. It comes from Lebanon. But archaeological evidence shows Egyptians were importing cedar for construction projects from the very beginning of the unified kingdom. How did they establish these long-distance trade networks so quickly? Third, there's the advanced understanding of human anatomy displayed in early Egyptian art and mummification practices. The Edwin Smith papyrus, though dating to the Second Intermediate Period, describes surgical procedures and anatomical knowledge that suggests centuries of accumulated medical wisdom. Fourth, there's the sophisticated understanding of metallurgy and chemistry shown in early Egyptian artifacts. The creation of faience, the production of different bronze alloys, the techniques for working with gold and silver all appear fully developed from the earliest periods. Think about learning a complex technical skill: surgery, metallurgy, astronomy, architecture. How long does it take to go from complete beginner to master level? Now think about developing these skills from scratch, without teachers or textbooks. The Egyptian timeline suggests they mastered multiple complex technologies simultaneously within a few centuries. Let's examine one specific case study that illustrates the knowledge problem: the construction of the Great Pyramid. This monument required not just architectural skill, but also advanced mathematics, surveying, logistics, and project management on a scale that wouldn't be attempted again for millennia. The pyramid contains approximately 2.3 million stone blocks, with an average weight of 2.5 tons each. Some blocks weigh as much as 15 tons. The precision of construction is extraordinary. The base is level 2, within just 2.1 centimeters, and the sides are equal in length to within 2 centimeters. The internal chamber system is equally impressive. The Grand Gallery is a corbelled vault, 47 meters long and 8.6 meters high, constructed with limestone blocks fitted so precisely that you can't slip a knife blade between them. The King's Chamber contains granite blocks weighing up to 70 tons, transported from quarries 800 kilometers away. Here's what bothers me. There's no evidence of practice runs. The Great Pyramid wasn't the result of gradual improvement over generations. Snefru's earlier pyramids at Dosha show experimental architecture, but they're contemporary with Giza, not predecessors. It's as if the Egyptians suddenly knew exactly how to build the most complex stone structure in the ancient world. The logistics alone should have taken decades to develop. Feeding, housing, and coordinating a workforce of 20,000 to 30,000 people. Transporting millions of tons of stone from quarries to construction site. Developing the specialized tools, ramps, and lifting devices needed for precise placement of massive blocks. If you've ever managed a large construction project, you know how many things can go wrong. The Great Pyramid project had to coordinate quarrying, transportation, construction, and provisioning on a massive scale with Bronze Age technology. What's your theory for how they pulled this off? The conventional explanation involves decades of preparation, sophisticated project management techniques, and innovative engineering solutions developed specifically for pyramid construction. But the lack of precedent still bothers me. You don't typically nail perfection on your first attempt at something this complex. There's another aspect of Egyptian culture that could support the knowledge transfer hypothesis. Their obsession with preserving and transmitting information. From the earliest periods, Egyptian priests were copying and recopying sacred texts, maintaining library collections, and training successors in traditional knowledge. This behavior makes sense if they were custodians of inherited wisdom, rather than innovators developing new knowledge. Cultures that develop knowledge organically tend to be more willing to modify and improve on tradition. Cultures that inherit knowledge from a revered source tend to focus on preservation and faithful transmission. The Egyptian concept of Mat cosmic order and balance also fits with this interpretation. Mat wasn't seen as something to be created or improved, but as a perfect state that needed to be maintained against the forces of chaos. This suggests a conservative worldview, focused on preserving existing perfection rather than pursuing innovation. Egyptian chronology provides another intriguing parallel to Plato's account. The Turin King list and other sources describe immensely long reigns for the earliest rulers, thousands of years in some cases. Mainstream historians interpret these as mythological exaggerations. But what if they represent compressed memories of a much longer period of cultural development? The Sphinx presents another chronological puzzle that could support the Atlantis connection. While mainstream archaeology dates the Sphinx to around 2500 BCE, some researchers argue that water erosion patterns on the monument suggest it's much older, possibly dating to the end of the last ice age. Geologist Robert Schoch has argued that the erosion patterns on the Sphinx enclosure walls are consistent with heavy rainfall, not wind and sand erosion. Since the last period of heavy rainfall in Egypt ended around 10,000 to 12,000 years ago. This would make the Sphinx roughly contemporary with Plato's Atlantis timeline. The mainstream response is that these erosion patterns could be caused by groundwater, surface runoff, or other factors besides direct rainfall. The debate continues, but it raises the possibility that some Egyptian monuments could be much older than currently believed. There's also the mystery of Egyptian astronomical knowledge. The ceiling of the tomb of Sinemet, dating to around 1450 BCE, shows a star map that includes constellations invisible to the naked eye. How did ancient astronomers know about stars they couldn't see? The precision of astronomical alignments in Egyptian architecture is equally puzzling. The Great Pyramid's alignment to true north is more accurate than the Paris Observatory, built in the 17th century. The temple at Dendera contains a circular zodiac that matches modern star charts with remarkable precision. Let's also consider the possibility that the knowledge transfer wasn't a one-time event, but an ongoing process. What if Atlantean survivors didn't just arrive in Egypt once, but maintained contact over generations? This could explain the sustained high quality of Egyptian civilization during the Old Kingdom period. Plato mentions that Atlantis controlled territories in North Africa and the Mediterranean. What if some of these territories survived the main catastrophe and continued to interact with early Egyptian civilization? This would provide a mechanism for continued knowledge transfer without requiring a massive refugee migration. The decline of Egyptian capabilities after the Old Kingdom could then be explained by the final collapse of these remaining Atlantean territories, cutting off the source of advanced knowledge and forcing Egyptian civilization to rely solely on its own resources. This hypothesis would be difficult to test archaeologically, since sustained cultural contact often leaves minimal physical evidence. Trade relationships, knowledge exchange, and cultural influence can operate for centuries without producing distinctive artifact assemblages. But there might be genetic evidence for population movement from the Atlantic region to Egypt during the relevant time period. Ancient DNA studies of early Egyptian populations could potentially identify markers indicating migration from North or West Africa during the late Pleistocene or early Holocene periods. Ancient DNA analysis is revolutionizing archaeology. If you're interested in how genetic research is changing our understanding of ancient migrations and population movements, check out our genetics playlist. But remember, absence of evidence isn't evidence of absence, especially with something as difficult to preserve as ancient DNA. We should also consider linguistic evidence. If Egyptian civilization received significant influence from Atlantis, we might expect to find linguistic connections. Unfortunately, we don't know what language the Atlanteans spoke, and Egyptian hieroglyphic writing doesn't preserve the spoken language well enough for detailed linguistic analysis. However, there are some intriguing parallels between Egyptian and other ancient languages that could support the knowledge transfer hypothesis. Egyptian mathematical and astronomical terminology shows similarities to Sumerian and Akkadian terms, suggesting possible common origins or cultural exchange. The Egyptian word for pyramid, mer, has been connected to words meaning place of ascension in several ancient languages. The word for pharaoh, para, meaning great house, has parallels in other cultures that suggest it might be a borrowed term rather than a native Egyptian word. Right, let's talk about one of the most dramatic periods in Earth's recent history, a time that coincides almost perfectly with Plato's timeline for the destruction of Atlantis. Around 12,900 years ago, the planet was warming up nicely after the last ice age. Then something happened that plunged the northern hemisphere back into near-glacial conditions for over 1,000 years. They call it the Younger Dryas, named after a cold-adapted flower that suddenly reappeared in the geological record across Europe. But calling it a cooling period is like calling a nuclear explosion a brief warming event. This was a climate catastrophe of biblical proportions. I want you to imagine this timeline. For thousands of years, ice sheets are melting, forests are returning, early humans are developing agriculture. Then, in the span of maybe a decade, temperatures plummet, ice sheets advance again, and much of the progress is wiped out. What could cause such a rapid reversal? For decades, the mainstream explanation was the collapse of ice dams holding back glacial Lake Agassiz in North America. According to this theory, massive amounts of fresh water suddenly dumped into the North Atlantic, disrupting ocean currents and triggering the climate reversal. It's a reasonable hypothesis, and there's evidence for major freshwater discharge during this period. But there's a problem. The Younger Dryas wasn't just a North Atlantic phenomenon. Cooling occurred simultaneously across the Northern Hemisphere, from Europe to North America to Asia. A regional freshwater event shouldn't have had such widespread impact. In 2007, a team of researchers led by Richard Firestone proposed a radical alternative. The Younger Dryas was triggered by a cosmic impact or series of impacts around 12,900 years ago. They called it the Younger Dryas Impact Hypothesis, and it's been one of the most controversial ideas in earth science ever since. The evidence for cosmic impact is complex and technical. We've got a detailed breakdown of the impact hypothesis in our catastrophe playlist. But here's the key question. Could the same cosmic event that triggered the Younger Dryas have also destroyed Plato's Atlantis? The impact hypothesis is based on several lines of evidence found in sediment layers dating to the Younger Dryas boundary. First, there's a layer of platinum enrichment found at over 170 sites across North America, Europe, and Asia. Platinum is rare in Earth's crust, but common in asteroids and comets. Second, there's widespread evidence of high-temperature events, magnetic microspherules, nanodiamonds, and fullerenes, with extraterrestrial isotope signatures. These materials form under extreme pressure and temperature conditions that are difficult to explain by normal terrestrial processes. Third, there's a sudden spike in biomass burning indicators, charcoal, soot, and carbon spherules, suggesting massive wildfires across multiple continents. The scale of burning indicated by these markers is unprecedented in the geological record. Fourth, there's evidence of sudden changes in ice core chemistry from Greenland and Antarctica, showing rapid atmospheric changes consistent with global environmental disruption. This is where science gets messy. The impact hypothesis has fierce supporters and equally fierce critics. Some researchers argue the evidence is compelling and points to multiple impacts or airbursts. Others argue it's misinterpreted normal geological processes. What's your take on controversial scientific theories? The criticism of the impact hypothesis has been intense and sometimes personal. Critics argue that the platinum anomaly could be caused by terrestrial processes, that the microspherules could form in normal fires, and that the nanodiamonds could be misidentified carbon structures. But the impact proponents have pushed back hard, providing additional evidence and refining their interpretations. They've identified impact craters that could date to the Younger Dryas period, including Hiawatha Crater under the Greenland ice sheet, which shows evidence of impact into ice. They've also pointed out that the evidence for impact isn't limited to the Younger Dryas boundary. Similar signatures appear at other major extinction events in Earth history, suggesting that cosmic impacts might be more common and more influential than previously recognized. Now, here's where this connects to our Atlantis investigation. The timing. Plato dates the destruction of Atlantis to approximately 11,600 years ago. The Younger Dryas began around 12,900 years ago and ended around 11,700 years ago. That puts the end of the Younger Dryas almost exactly at Plato's timeline. Could Atlantis have survived the initial cosmic impact that triggered the Younger Dryas, only to be destroyed by the environmental chaos that followed? Or could there have been multiple impact events, with the final one destroying the remnants of Atlantean civilization around 11,600 years ago? Look at these dates. Younger Dryas begins 12,900 years ago. Plato's Atlantis destroyed 11,600 years ago. Younger Dryas ends 11,700 years ago. That's a correlation that's hard to ignore. Coincidence or connection? If cosmic impacts were involved in destroying Atlantis, they could explain several puzzling aspects of Plato's account. First, the sudden, catastrophic nature of the destruction. In one day and one fatal night, cosmic impacts can cause devastating earthquakes, tsunamis, and environmental collapse within hours. Second, the association with earthquakes and floods. Large impacts generate massive seismic waves that can be felt thousands of kilometers away. They can also trigger tsunamis if they occur in or near bodies of water. Third, the global scope of the catastrophe. Plato mentions that both Athens and Atlantis were destroyed in the same event. A major cosmic impact could have environmental effects spanning continents, causing simultaneous civilizational collapse across large regions. The impact hypothesis could also explain how Atlantis became impossible to pass and search after its destruction. If the island was hit by or near a cosmic impact, the resulting environmental changes altered sea levels, changed ocean currents, debris fields could have made the area inaccessible to ancient navigation. There's another intriguing aspect of the Younger Dryas that connects to our investigation: the effect on sea levels and coastal geography. During the Younger Dryas, massive amounts of water were locked up in reformed ice sheets, causing sea levels to fluctuate dramatically. Imagine trying to maintain a maritime civilization during a period when sea levels are dropping by dozens of meters, then rising again, then dropping. Harbors would become useless. Coastal cities would be alternately flooded and stranded inland. It's a recipe for civilizational collapse. The end of the Younger Dryas was equally dramatic. As the climate rapidly warmed around 11,700 years ago, ice sheets collapsed, sending massive volumes of meltwater into the oceans. Sea levels rose by dozens of meters within centuries, fast enough to drown coastal settlements, but slow enough for some populations to relocate. This timing could explain the survival and migration of Atlantean knowledge to places like Egypt. If Atlantis was destroyed around 11,600 years ago during the final collapse of Younger Dryas ice sheets, survivors would have had to flee rising seas and seek new homes. The direction of that migration makes geographical sense. If Atlantis was located in the Atlantic region, whether at the Richat structure or elsewhere along the African coast, survivors fleeing rising seas would naturally move inland and eastward, potentially reaching the Nile Valley. The timing also fits with the beginning of Egyptian civilization. While mainstream archaeology dates unified Egyptian culture to around 3100 BCE, there's evidence of sophisticated cultural development in the Nile Valley going back to at least 5000 BCE, with some sites showing even earlier complexity. If Atlantean refugees arrived in the Nile Valley around 11,600 years ago, they would have had thousands of years to establish settlements, develop local adaptations, and gradually build the civilization that would eventually become dynastic Egypt. Think about refugee movements in modern times, how populations spread, where they settle, how they integrate with existing communities. If you were modeling the migration of Atlantean survivors, where would you expect them to end up? The Nile Valley, the Mediterranean coast, the Atlas Mountains. There's archaeological evidence that could support this migration scenario. Sites like Nabta Playa in southern Egypt show evidence of sophisticated astronomical knowledge dating to around 7,000 to 5,000 BCE. Stone circles at the site appear to be aligned with stellar positions and show understanding of precession and other complex astronomical cycles. The people who built Nabta Playa had knowledge that wasn't matched again in the archaeological record until the rise of Egyptian civilization thousands of years later. Could this represent a link between Atlantean astronomical knowledge and later Egyptian achievements? Göbekli Tepe in Turkey presents another intriguing parallel. This massive stone complex, dating to around 9500 BCE, shows sophisticated architectural and artistic knowledge appearing suddenly in the archaeological record. The site was deliberately buried around 8000 BCE, as if the builders wanted to preserve it for future discovery. Could Göbekli Tepe represent another settlement of Atlantean survivors, preserving their knowledge in monumental form before the final collapse of their civilization? The timing: construction around 9500 BCE, abandonment around 8000 BCE fits with a gradual decline following the main Atlantean catastrophe. The cosmic impact hypothesis also provides a mechanism for the preservation of Atlantean historical records in Egyptian temples. If Atlantean survivors brought written records or oral traditions with them to Egypt, these could have been incorporated into Egyptian historical accounts and preserved by Egyptian priests. Think about how historical knowledge is preserved during civilizational collapse. Usually it's through religious institutions, monasteries, temples, libraries. If Atlantean historical records survived the catastrophe, where would they most likely be preserved? In Egyptian temple libraries, perhaps. This could explain how the story of Atlantis reached Plato through Egyptian sources. Rather than being a philosophical invention, it could represent genuine historical memory preserved in Egyptian temple records and transmitted to Greek scholars like Solon. The level of detail in Plato's account, the specific geographical descriptions, the precise measurements, the complex political structure, makes more sense as preserved historical information than as pure literary creation. But we need to be careful about confirmation bias here. The correlation between the Younger Dryas timeline and Plato's Atlantis timeline could be coincidental. Ancient peoples were well aware of catastrophic climate changes and could have incorporated them into mythological accounts without direct historical connection. The cosmic impact hypothesis itself remains controversial, with ongoing debate about the interpretation of the geological evidence. Even if the impact hypothesis is correct, it doesn't necessarily prove that a technologically advanced civilization like Atlantis existed at that time. However, the Younger Dryas period does represent one of the most dramatic environmental changes in recent geological history. Any advanced civilization existing at that time would have faced unprecedented challenges to survival. If you were part of an advanced coastal civilization facing the Younger Dryas catastrophe, climate collapse, rising and falling sea levels, environmental chaos lasting over 1,000 years, what would be your survival strategy? How would you preserve your knowledge and culture? The environmental pressures of the Younger Dryas could explain why we don't see more archaeological evidence of advanced pre-Younger Dryas civilizations. Coastal settlements would have been destroyed by changing sea levels. Inland sites would have been abandoned due to climate change. Only the most robust stone monuments or deeply buried sites would survive. This makes the search for Atlantean archaeological evidence more challenging but not impossible. We need to look in the right place, says areas that were habitable during the pre-Younger Dryas period but protected from the worst environmental changes. The Richat structure fits these criteria perfectly. It's elevated above sea level changes. It's in an area that was habitable during the African humid period, and it's geologically stable enough to preserve evidence over 12,000 years. Right, we've laid out the case for an Atlantis-Egypt connection. We've examined the geographical match between the Richat structure and Plato's description. We've explored Egypt's mysterious rapid rise to civilization. We've connected the timeline to the Younger Dryas catastrophe. Now comes the hard part. How do we test this hypothesis scientifically? Because here's the thing, extraordinary claims require extraordinary evidence. And right now, what we have is a compelling collection of correlations, coincidences, and intriguing possibilities. But correlation isn't causation, and possibilities aren't proof. Before we dive into testing methods, I want to know, what's your standard of proof for historical claims? Archaeological artifacts, multiple independent sources, genetic evidence, scientific dating. Tell me in the comments what would convince you one way or the other. Let's start with the most direct approach. Archaeological investigation of the Richat structure. If this really is the remains of Atlantis, we should be able to find physical evidence of human habitation and construction dating to around 11,600 years ago. The first step would be a comprehensive remote sensing survey using the latest technology. We're talking about high-resolution satellite imagery, synthetic aperture radar, LiDAR scanning, and multispectral analysis. These techniques can reveal buried structures, ancient shorelines, and subsurface anomalies that aren't visible to the naked eye. Ground-penetrating radar would be particularly valuable for identifying buried architectural remains. GPR can detect stone foundations, wall alignments, and void spaces to depths of several meters. If there are buried structures within the Richite rings, GPR should be able to map them. Magnetometry is another crucial tool. Human activity fires, metalworking, construction leaves, distinctive magnetic signatures in the soil. A comprehensive magnetic survey of the Richite structure could identify areas of intensive human activity, even if surface evidence has been eroded away. Archaeological technology has advanced dramatically in recent years. We've got videos exploring how ground-penetrating radar, LiDAR, and satellite archaeology are revolutionizing the field. Links in the description if you want to see how this stuff actually works. But remote sensing is just the beginning. We'd need systematic surface surveys to collect and analyze artifacts. The Sahara Desert is actually excellent for artifact preservation. The dry climate and stable conditions can preserve organic materials for thousands of years. Any systematic occupation of the Richite structure should have left traces. Stone tools, pottery fragments, food remains, fire hearthstones. The complete absence of such evidence would be a major blow to the Atlantis hypothesis. Their presence, especially if dated to the right time period, would be revolutionary. Soil sampling would be essential for identifying ancient occupation layers. Human habitation leaves distinctive geochemical signatures, elevated phosphorus levels from food waste, ash layers from fires, organic compounds from decomposed materials. Core samples from the ring basins could reveal whether they ever held standing water and when. If we found promising areas through remote sensing and surface survey, the next step would be targeted excavations. Small test trenches in high-probability locations could reveal stratified deposits, architectural remains, and datable materials without massive disruption to the site. Archaeological excavation is destructive. Once you dig up a site, you can't put it back. How do we balance the desire for answers with a responsibility to preserve sites for future research? Should we excavate the Richite structure or wait for better technology? Dating would be absolutely crucial for any discoveries. We'd need multiple independent dating methods. Radiocarbon dating for organic materials, optically stimulated luminescence dating for quartz grains, thermoluminescence dating for heated stones or pottery. The dates would need to cluster around the 11,600 year mark to support Plato's timeline. Earlier dates might indicate pre-Atlantean occupation. Later dates would suggest post-catastrophe settlement. A complete absence of dates in the right range would effectively falsify the hypothesis. But archaeological investigation of the Richite structure is just one line of evidence. We'd also need to test the proposed connections between Atlantis and Egyptian civilization. Genetic analysis of ancient Egyptian populations could reveal evidence of migration from North or West Africa during the relevant time period. Ancient DNA extraction from early Egyptian mummies and skeletal remains is becoming increasingly sophisticated. If significant numbers of Atlantean refugees reached Egypt around 11,600 years ago, we might expect to see genetic markers indicating population mixing between local Nile Valley peoples and migrants from the Atlantic region of Africa. Ancient DNA is revolutionizing our understanding of human migration and cultural exchange. If you're interested in how genetic archaeology works, we've got an entire playlist covering recent discoveries. But remember, negative results don't disprove the hypothesis. Ancient DNA is difficult to preserve and extract. Linguistic analysis could provide another line of evidence. While we can't reconstruct spoken ancient Egyptian with complete accuracy, we can analyze the written language for borrowed terms, especially technical vocabulary related to mathematics, astronomy, and architecture. If Egyptian civilization received significant knowledge transfer from Atlantis, we might expect to find non-Egyptian linguistic roots for specialized terminology. This would be particularly telling for concepts that appear suddenly in the historical record without apparent local development. Cultural analysis could reveal patterns of knowledge transmission. We'd need to map the geographical and temporal spread of specific technologies, architectural techniques, and symbolic systems across North Africa and the Eastern Mediterranean. If Atlantean knowledge really did spread from a Western source, we should see evidence of westward to eastward cultural transmission during the late Pleistocene and early Holocene periods. Technologies and ideas should appear first in Western regions and spread eastward over time. Think about how cultural innovations spread in the modern world. They usually diffuse outward from centers of innovation. If we mapped the appearance of advanced architectural and mathematical knowledge across ancient North Africa, what pattern would we expect to see if it originated from Atlantis? Geological testing of the flooding hypothesis would be crucial. If the rich art structure was ever connected to the Atlantic by waterways, we should find sedimentary evidence, marine fossils, salt deposits, flow patterns carved into bedrock. Core samples from the supposed canal routes and ring basins could reveal whether they ever contained seawater or freshwater, and when. Isotope analysis of preserved minerals could distinguish between marine and terrestrial water sources. We'd also need to model paleo-sea levels and river systems for the end Pleistocene period. Could rising seas or catastrophic flooding have temporarily connected the Richet region to the Atlantic around 11,600 years ago? Computer modeling using the latest climate data could test this possibility. The cosmic impact hypothesis provides another testable element. If the destruction of Atlantis was connected to younger Dryas impact events, we should find impact signatures in the right geographical area and time period. Impact materials, shocked minerals, metallic spherules, fullerenes with extraterrestrial isotope ratios should be present in sediment layers dating to around 11,600 years ago. The distribution pattern of these materials could help identify impact locations. Cosmic impact signatures are being found at more and more archaeological sites worldwide. If you're interested in the cutting-edge research on cosmic impacts and human civilization, check out our Catastrophism playlist. The evidence is pretty mind-blowing. Here's what a comprehensive research program would look like. Phase 1 would involve non-invasive remote sensing of the Richet structure, satellite analysis, aerial survey, geophysical mapping. This could be done relatively quickly and cheaply, providing a baseline for more intensive investigation. Phase 2 would involve surface survey and limited sampling artifact collection, soil chemistry analysis, targeted core sampling. This would test whether there's any evidence of human occupation without major excavation. Phase 3 would involve targeted excavations based on Phase 2 results. Small test trenches in the most promising areas, with comprehensive dating and analysis of any findings. Parallel research tracks would investigate the Egyptian connection through genetic analysis, linguistic research, and cultural mapping. These could proceed independently of the rich art investigation and provide supporting or contradicting evidence. The timeline for such a program would be substantial, probably 5 to 10 years, for comprehensive results. The cost would be significant but not prohibitive, probably comparable to major archaeological projects, like the investigation of Pompeii or Angkor Wat. But here's the crucial point. This research program would be designed to falsify the hypothesis, not confirm it. We'd be looking for evidence that could definitively rule out the Atlantis connection, not just evidence that might support it. This is how real science works. You try to prove yourself wrong, not right. What kind of evidence would definitively disprove the Richard Atlantis connection for you? Complete absence of artifacts, geological dating that rules out human occupation. Something else, a negative result would be scientifically valuable. If comprehensive investigation found no evidence of ancient human occupation at the Richard structure, it would help settle the Atlantis debate and redirect research toward more promising avenues. A positive result would be revolutionary. Archaeological evidence of a sophisticated civilization at the Richard structure dating to 11,600 years ago would fundamentally change our understanding of human cultural development. But there's a middle possibility that's perhaps most likely. Ambiguous results that neither definitively prove nor disprove the hypothesis. Some evidence of ancient human presence, but not clearly sophisticated enough to represent Plato's Atlantis. Some geological evidence of ancient water features, but not clearly artificial harbors. This is actually the most common outcome in archaeology. Clean, definitive answers are rare. Most archaeological questions involve weighing partial evidence, competing interpretations, and degrees of probability rather than absolute proof. The standards of evidence need to be appropriate to the claim. Extraordinary claims like the existence of a lost advanced civilization require more robust evidence than ordinary archaeological hypotheses. How much evidence would you need to accept that the Richard structure is Atlantis? Multiple, independent lines of evidence. Peer-reviewed publications. International scientific consensus. Or would you need to see the artifacts yourself? There's another important aspect to consider. Even if the Richard structure isn't Atlantis, investigating it scientifically would advance our understanding of North African prehistory, Saharan paleoclimatology, and early human cultural development. The region has been understudied due to political instability and harsh environmental conditions. A major research program focused on the Richard structure would generate valuable scientific knowledge, regardless of its connection to Atlantis. This is actually how good archaeological research works. You investigate interesting sites and anomalies not because you know what you'll find, but because the investigation itself will generate new knowledge and test existing theories. The Atlantis hypothesis provides motivation and funding justification for research that might not otherwise happen. Even if the hypothesis is ultimately rejected, the research process could reveal important information about human cultural development during a crucial period of climate change. We should also consider the possibility of partial confirmation. Maybe the Richard structure was occupied by an ancient civilization, but not one as advanced as Plato described. Maybe there was cultural transmission from North Africa to Egypt, but not from specifically Atlantean refugees. Most historical accounts contain elements of both truth and fiction. If parts of Plato's Atlantis account proved to be based on real events, but other parts were clearly mythological embellishment, how would that change your perspective on ancient historical sources? The investigation methodology would need to account for these partial possibilities, rather than simply looking for evidence that confirms or rejects the full Atlantis hypothesis. We'd need to design research that could identify and evaluate different levels of correspondence between Plato's account and the archaeological record. This kind of nuanced approach is more scientifically rigorous than simple hypothesis testing. It acknowledges that historical reconstruction is complex and that ancient sources often contain mixtures of accurate information, cultural interpretation, and literary embellishment. The research would also need international collaboration and transparency. The Atlantis question has been contaminated by decades of pseudoscientific speculation and nationalist mythology. Any serious investigation would need impeccable scientific credentials and open publication of methods and results. Citizen science could play a valuable role. Satellite imagery analysis, artifact identification, and pattern recognition are tasks that can be crowdsourced to engaged amateur researchers. The archaeological community has successfully used citizen science for site identification and preliminary analysis. You can actually contribute to archaeological research right now. Platforms like DigVentures and GlobalExplore let anyone help analyze satellite imagery and identify potential archaeological sites. Links in the description if you want to get involved. The political and logistical challenges would be substantial. The rigid structure is located in a remote region of Mauritania, with limited infrastructure and occasional security concerns. International research collaboration would require diplomatic coordination and significant logistical planning. But these challenges aren't insurmountable. Major archaeological projects have been successfully conducted in challenging environments worldwide. The potential scientific payoff would justify the effort and expense. Time is also a factor. Climate change and human activity are gradually altering the Saharan environment. Sites that are accessible and well preserved today might be compromised or destroyed in the future. Archaeological investigation of the region shouldn't be delayed indefinitely. The research would also need to respect local communities and cultural sensitivities. The Richat structure has cultural significance for local populations, and any research program would need to involve local stakeholders and provide benefits to local communities. Let's step back for a moment and consider what we're really talking about here. If the Atlantis-Egypt connection has any validity, if there's even a grain of truth to the idea that advanced knowledge was transmitted from an earlier civilization to the founders of Egyptian culture, it would fundamentally change how we understand human history. We're not just talking about rewriting a few chapters in archaeology textbooks. We're talking about challenging one of the most basic assumptions of modern historical science: the idea that human cultural development has been essentially linear, progressive, and cumulative. Think about how we usually understand history. Hunter-gatherers develop agriculture. Agriculture leads to cities. Cities develop writing and technology. Complexity gradually increases over time. What if that's not the whole story? What if there have been cycles of rise and fall we don't know about? The conventional model of human cultural development is often called the Whig interpretation of history, the idea that human societies naturally progress from simple to complex, from primitive to advanced, in a generally upward trajectory with occasional setbacks. This model works well for the period from about 3000 BCE to the present, where we have good archaeological and historical records. We can trace the development of writing, metallurgy, mathematics, and other technologies with reasonable confidence. But it becomes much more speculative when we try to extend it back into the Pleistocene period, the time before agriculture, before permanent settlements, before the kinds of archaeological sites that preserve well in the geological record. The assumption has been that Pleistocene humans were essentially hunter-gatherers with simple technology and social organization. Any complex knowledge or sophisticated culture we see in early historical periods must have developed after the end of the Ice Age. Here's a thought experiment. If our own civilization collapsed tomorrow and archaeologists, 10,000 years from now, tried to reconstruct our culture, what would survive? Stone buildings might last, but most of our technology, computers, books, vehicles, would be gone. Could they accurately reconstruct our level of advancement? But this assumption is increasingly challenged by new archaeological discoveries. Sites like Göbekli Tepe in Turkey, dating to around 9500 BCE, show sophisticated architecture and artistic expression appearing much earlier than the conventional model predicts. Göbekli Tepe required advanced planning, specialized craftsmanship, and the ability to coordinate large workforces, all capabilities that suggest much more complex social organization than we typically associate with early Holocene hunter-gatherers. Similar sites are being discovered worldwide. Poverty Point in Louisiana, 1700 BCE. Caral in Peru, 3500 BCE. The megalithic temples of Malta, 3600 BCE. Each one pushes back the dates for sophisticated architecture and social organization. The pattern suggests that human cultural capacity has been consistently underestimated for prehistoric periods. This could be due to preservation bias. Complex, wooden or organic structures don't survive as well as simple stone tools, or discovery bias. We've been looking in the wrong places for the wrong things. If the Atlantis hypothesis has any validity, it would suggest that this pattern extends much further back in time than currently recognized. It would imply that sophisticated civilizations might have existed during the Pleistocene period and contributed to later cultural development through knowledge transmission. The idea of lost civilizations is compelling but scientifically challenging. What level of evidence would you need to accept that a sophisticated civilization existed 15,000 or 20,000 years ago? And why is this idea so appealing to people? This has implications beyond archaeology and history. It touches on fundamental questions about human nature and cultural development. Are humans naturally progressive, gradually building knowledge and complexity over time? Or are we capable of dramatic rises and falls in cultural sophistication? Modern examples suggest both patterns are possible. Some societies have shown remarkable cultural continuity over millennia. China, for example, has maintained recognizable cultural patterns for over 3,000 years. Other societies have experienced dramatic collapse and rebuilding. The fall of Rome, the collapse of Maya civilization, the Bronze Age collapse around 1200 BCE. The Atlantis hypothesis would suggest that such collapse and rebuilding cycles might extend much further back in human history than we currently recognize. This would make human cultural development less predictable and more contingent on environmental and historical factors. Climate science provides a context for understanding how environmental changes could drive cultural cycles. The Pleistocene period was characterized by dramatic climate swings, ice ages alternating with warm periods, rapid changes in sea level, shifts in precipitation patterns, and ecosystem boundaries. Any human societies that developed sophisticated culture during this period would have faced enormous environmental pressures. The successful societies would have been those that could adapt to rapid change, preserve knowledge through difficult periods, and rebuild after environmental catastrophes. We're facing our own period of rapid climate change right now. What can we learn from how ancient societies dealt with environmental pressures? Are there lessons from the past that could help us build more resilient civilizations? The knowledge preservation aspect is particularly intriguing. How do societies maintain complex knowledge through periods of crisis? Historical examples suggest it often happens through institutional mechanisms, religious orders, craft guilds, scholarly traditions that specialize in preserving and transmitting information. If Atlantean knowledge was preserved and transmitted to Egyptian civilization, it would have required sophisticated institutional mechanisms for knowledge preservation. This suggests that even if the main civilization collapsed, some organized communities of knowledge keepers must have survived. This pattern appears in historical examples of civilizational collapse. When the Western Roman Empire fell, much classical knowledge was preserved in monasteries and Islamic libraries. When the Maya cities were abandoned, some communities maintained astronomical and calendrical knowledge for centuries. The Egyptian priesthood fits this pattern perfectly. They were explicitly tasked with preserving sacred knowledge, maintaining temple libraries, and transmitting traditional wisdom across generations. If they were also preserving Atlantean historical records, it would be consistent with their established role as knowledge keepers. The implications extend to how we interpret other ancient sources. If Plato's account contains genuine historical information preserved through Egyptian sources, what about other ancient accounts of lost civilizations or cultural heroes? How should we evaluate ancient historical accounts that seem implausible by modern standards? Stories of great floods, advanced ancient civilizations, culture heroes who brought knowledge from distant lands, should we dismiss them as mythology or investigate them as potential historical memory? Flood myths, for example, are found in cultures worldwide: the biblical flood, the Mesopotamian flood epics, Hindu flood stories, Native American flood traditions, Australian Aboriginal flood myths. The conventional explanation is that these represent common human responses to local flooding events. But what if they represent cultural memories of actual global flooding events, like the rapid sea level rises at the end of the last ice age? Recent research suggests that post-glacial flooding was more rapid and dramatic than previously thought, with some coastal areas experiencing several meters of sea level rise within centuries. Culture hero myths, stories of divine or semi-divine figures who bring knowledge to humanity, also appear worldwide. Prometheus bringing fire to humanity, Quetzalcoatl teaching agriculture and astronomy to the Mesoamericans, Oannes bringing civilization to the Babylonians. If these stories represent cultural memories of actual knowledge transmission from earlier civilizations, they would provide a different framework for understanding early cultural development, not as independent invention, but as the inheritance and adaptation of older wisdom traditions. This doesn't necessarily support ancient astronaut theories or other fringe ideas. Knowledge transmission between human societies is well documented throughout history. The unusual aspect would be the time depth, the possibility that such transmission occurred over much longer time periods than currently recognized. The implications for understanding technological development would also be significant. Instead of assuming that all complex technologies were independently invented multiple times, we might need to consider the possibility of much earlier invention, followed by transmission, loss, and rediscovery. Think about how quickly technologies spread in the modern world's smartphones, internet protocols, medical techniques. What if similar rapid technology transfer occurred in the ancient world, but over longer timescales and with less documentation? Consider the example of concrete. The Romans developed sophisticated concrete technology that was then lost after the fall of the Western Empire and not fully rediscovered until the modern era. What if similar losses and rediscoveries occurred multiple times over longer historical periods? Or consider navigation technology. Polynesian navigators developed sophisticated techniques for ocean navigation that allowed them to settle islands across thousands of kilometers of open ocean. These techniques were preserved through oral tradition and practical training, with minimal archaeological evidence. If Atlantean civilization developed sophisticated maritime technology, it might have been transmitted through similar oral and practical traditions, leaving little archaeological trace but contributing to the development of later maritime cultures. The question isn't whether such knowledge transmission is possible. We know it happens throughout history. The question is whether it happened over the timescales and distances suggested by the Atlantis hypothesis. This brings us back to the fundamental challenge of prehistoric archaeology. The further back in time we look, the less evidence survives, and the more we have to rely on indirect indicators and theoretical models. But that doesn't mean we should abandon the attempt to understand deep human history. It means we need to be more creative in our research methods, more open to unexpected possibilities, and more careful about distinguishing between evidence and assumption. Right, I've been making the case for a possible Atlantis-Egypt connection for the better part of 2 hours. But I'd be doing you a disservice if I didn't present the skeptical perspective with equal rigor. Because the truth is, most mainstream archaeologists and historians think the whole idea is complete bollocks. And they have good reasons for that skepticism. This is crucial for evaluating any controversial claim. You need to understand the strongest arguments on all sides. I want you to approach the next few minutes with your most critical mindset. What are the weaknesses in the case I've been building? Let's start with the most fundamental problem: the complete lack of unambiguous archaeological evidence. We've talked about correlations, correspondences, and possibilities. But we don't have a single artifact, structure, or inscription that definitively proves the existence of a sophisticated civilization matching Plato's description at the time and place. He specified, "This isn't like other controversial archaeological questions where we have competing interpretations of existing evidence. This is a case where we have virtually no direct evidence at all." And in archaeology, absence of evidence isn't proof of absence, but it's not proof of presence either. The rich art structure, for all its visual similarity to Plato's description, remains what mainstream geology says it is: a natural, eroded dome. Despite decades of speculation and occasional expeditions, no one has found convincing evidence of artificial modification or ancient human occupation dating to the relevant time period. The stone tools found in the region date to much later periods and are consistent with typical Neolithic occupation, not with a sophisticated urban civilization. There are no harbor installations, no building foundations, no sophisticated artifacts. No evidence of the complex society Plato described. Put yourself in the position of a professional archaeologist. You've got limited funding, limited time, and a responsibility to pursue research that will advance knowledge. Would you invest resources in investigating speculative connections to Atlantis, or would you focus on sites with proven archaeological potential? The geological arguments for ancient flooding of the Richat region are also problematic. While the Sahara was indeed wetter during the early Holocene, and sea levels were different, the specific conditions required for Plato's description deep water navigation to a ringed island city have not been demonstrated. The elevation of the Richat structure, its distance from the ocean, and the lack of clear evidence for substantial water bodies in the region during the relevant time period all argue against the maritime civilization scenario. Computer modeling of paleo sea levels and river systems doesn't support the idea that the Richat region was accessible to ocean-going vessels during the late Pleistocene or early Holocene periods. The environmental reconstruction simply doesn't match Plato's geographical requirements. Then there's the Egypt problem. Mainstream Egyptology has a well-developed understanding of how Egyptian civilization developed, based on extensive archaeological investigation spanning more than a century. This understanding doesn't require external input from a lost civilization. The development of Egyptian culture can be traced through clear archaeological sequences, pre-dynastic cultures showing gradual, increasing complexity. Experimental architecture leading to mature pyramid construction, the evolution of writing systems from simple symbols to complex hieroglyphs. Occam's razor suggests that the simplest explanation that fits the facts is usually correct. Is it simpler to explain Egyptian civilization as natural cultural development, or as inheritance from a lost advanced civilization for which we have no independent evidence? The supposed sudden appearance of Egyptian sophistication is largely an artifact of our historical perspective. From our modern viewpoint, a few centuries seems rapid. But a few centuries is plenty of time for significant cultural development, especially under the environmental and social pressures that existed in the Nile Valley during the late pre-dynastic period. The precision of Egyptian monuments, while impressive, is within the capabilities of Bronze Age technology given sufficient time, resources, and motivation. Experimental archaeology has demonstrated that the construction techniques needed for pyramid building could have been developed using available technology and methods. The mathematical and astronomical knowledge displayed in Egyptian monuments, while sophisticated, doesn't require external teaching. It could have developed through generations of careful observation and practical application by Egyptian astronomers and architects. The quality decline in later Egyptian construction is easily explained by changing political, economic, and cultural priorities. The Old Kingdom represented a unique period of centralized authority and resource concentration that was never fully repeated in later periods. The Plato problem remains fundamental. We have no independent corroboration for his account from any other ancient source. Despite extensive exploration of Egyptian, Mesopotamian, and other ancient archives, no other civilization mentions Atlantis or anything clearly corresponding to Plato's description. How do historians evaluate ancient sources? What makes a source reliable or unreliable? Should we treat Plato's account differently from other ancient historical claims? And if so, why? The level of detail in Plato's account, which supporters see as evidence of historical authenticity, can also be interpreted as evidence of literary sophistication. Ancient writers were perfectly capable of creating elaborate fictional worlds with convincing details, as demonstrated by works like Homer's Odyssey or Virgil's Aeneid. Plato was not primarily a historian but a philosopher, and his other works show a willingness to use fictional scenarios to explore philosophical themes. The Republic, for example, describes an ideal state that Plato clearly didn't intend as historical fact. The Atlantis account appears in dialogues explicitly designed to explore philosophical questions about ideal societies, political corruption, and divine justice. Reading it as historical fact rather than philosophical allegory may fundamentally misunderstand Plato's intentions. The timing correlations with the younger Dryas, while intriguing, could be coincidental. Ancient peoples were well aware of climate changes and natural catastrophes, and could incorporate them into fictional or mythological accounts without direct historical experience. The younger Dryas impact hypothesis itself remains controversial within the scientific community. Even if cosmic impacts occurred during this period, it doesn't follow that they destroyed a specific advanced civilization matching Plato's description. Be honest. Are you looking for evidence that supports the Atlantis hypothesis? Or are you objectively evaluating all evidence? How do you guard against confirmation bias when investigating ideas you find appealing? The pattern matching between the Richard structure and Plato's description, while visually striking, may be an example of apophenia, the human tendency to perceive meaningful patterns in random information. Humans are extraordinarily good at finding patterns and connections, even when they don't exist. Given the number of circular geological formations on Earth and the relatively simple description Plato provides, some degree of correspondence would be expected by chance. The question is whether the correspondence is specific and detailed enough to exceed what we would expect from random matching. The cultural parallels between Atlantean and Egyptian civilization, as described by Plato, are also problematic as evidence. Many of these features, divine kingship, monumental architecture, astronomical knowledge appear in multiple ancient civilizations independently. This suggests that such features represent common patterns in the development of complex societies, rather than evidence of specific cultural transmission from Atlantis to Egypt. The genetic evidence that would be needed to support massive migration from North Africa to the Nile Valley during the relevant time period simply doesn't exist. While ancient DNA research is advancing rapidly, current evidence doesn't support the population movements that would be required by the Atlantis hypothesis. The linguistic evidence is similarly lacking. While Egyptian contains some words of unclear etymology, this doesn't necessarily indicate borrowing from a sophisticated lost civilization. It could equally well indicate borrowing from other contemporary cultures or natural linguistic evolution. For every piece of evidence supporting the Atlantis hypothesis, can you think of alternative explanations that don't require a lost civilization? Which explanations seem more plausible based on what we know about human history and cultural development? The institutional mechanisms that would be required to preserve Atlantean knowledge through the Egyptian priesthood are speculative. While Egyptian priests did preserve traditional knowledge, there's no evidence that this knowledge included historical records from a pre-existing advanced civilization. The broader implications for understanding human cultural development, while intellectually interesting, are not supported by the current archaeological record. The conventional model of gradual cultural development, while not perfect, fits the available evidence better than models requiring major knowledge transmission from lost civilizations. Recent archaeological discoveries, like Göbekli Tepe, while pushing back dates for complex society, don't require explanations involving lost advanced civilizations. They can be understood as examples of human cultural capacity being consistently underestimated, without requiring external knowledge sources. The time depth problem is also significant. Preserving specific technological and cultural knowledge across 12,000 years would require institutional continuity that has no parallel in documented history. Even the longest-lasting human institutions, like the Chinese imperial system or the Catholic Church, show major changes and knowledge losses over much shorter time periods. Finally, there's the question of motivation and methodology. Much of the research promoting Atlantis connections has been conducted by non-specialists with strong prior commitments to proving the hypothesis. This creates concerns about confirmation bias and methodological rigor. Professional archaeologists and historians, with their training in source criticism, field methods, and peer review, remain overwhelmingly skeptical of Atlantis claims. This skepticism isn't based on closed-mindedness, but on standards of evidence that have proven effective in other historical investigations. So where does this leave us after 2 hours of investigation? We've examined the geographical correspondence between the Richat structure and Plato's Atlantis. We've explored the mysterious rapid rise of Egyptian civilization. We've considered the timeline correlations with the Younger Dryas catastrophe. We've looked at the evidence for and against the hypothesis. What's the verdict? Before I give you my assessment, I want to hear yours. Based on everything we've covered, do you think there's a connection between Atlantis and ancient Egypt? Are you more convinced than when we started, less convinced, or about the same? Hit the poll and tell me. Here's my honest assessment. The case for an Atlantis-Egypt connection remains unproven but not definitively disproven. We have intriguing correlations, thought-provoking possibilities, and questions that deserve further investigation. But we don't have the kind of hard evidence that would convince a skeptical scientific community. The Richat structure is a remarkable geological formation that bears a striking resemblance to Plato's description of Atlantis. The geographical context, the ring structure, the color variations, the size relationships, they're all surprisingly close to what Plato described. But resemblance isn't proof, and natural formations can create patterns that mimic artificial structures. Egyptian civilization did develop with remarkable speed and sophistication, reaching heights that weren't matched again for millennia. The precision of the pyramids, the complexity of the mathematics, the astronomical knowledge, they all suggest capabilities that developed faster than we might expect from a purely indigenous process. But rapid cultural development isn't unprecedented in human history. Under the right environmental and social conditions, human societies can achieve remarkable things in relatively short time periods. The Egyptian achievement, while impressive, falls within the range of documented human cultural capacity. Think about rapid cultural changes in recorded history. The Renaissance in Europe, the scientific revolution, the industrial revolution, the digital age. Humans are capable of dramatic cultural leaps when conditions are right. Does the Egyptian achievement really require external explanation? The timeline correlations with the Younger Dryas are intriguing but not conclusive. The end of the Ice Age was a period of dramatic environmental change that affected human societies worldwide. It's plausible that such changes could have destroyed advanced civilizations. But it's also plausible that they could have stimulated cultural development among surviving populations. The cosmic impact hypothesis for the Younger Dryas provides a possible mechanism for the catastrophic destruction Plato described. But the impact hypothesis itself remains controversial, and even if accepted, it doesn't prove that Atlantis was among the casualties. So, where does this leave us? I think the honest answer is that we need more research. The questions raised by the Atlantis hypothesis are scientifically legitimate and deserve investigation. But they require the kind of rigorous, systematic research that has rarely been applied to this topic. A properly designed research program investigating the Richat structure could settle at least part of the question. If comprehensive archaeological investigation found no evidence of ancient human occupation during the relevant time period, it would effectively refute the Richat-Atlantis connection. If investigation found evidence of sophisticated human occupation dating to around 11,600 years ago, it would be revolutionary regardless of whether the site was Plato's Atlantis or some other unknown civilization. If you could fund one research project to investigate the Atlantis question, what would it be? Archaeological excavation of the Richat structure, genetic analysis of ancient Egyptian populations, linguistic analysis of early Egyptian texts, climate modeling of post-glacial North Africa, The broader questions about human cultural development raised by the Atlantis hypothesis are also worth pursuing. How quickly can human societies develop complex technologies and knowledge systems? How is knowledge preserved and transmitted during periods of crisis? How do we account for the apparent sophistication of some early civilizations? These questions don't require belief in Atlantis to be interesting and important. They're fundamental questions about human cultural capacity and historical development that have implications for understanding both past and future. The methodological lessons are also important. The Atlantis investigation demonstrates both the value and the limitations of pattern matching, correlation analysis, and circumstantial evidence. These tools can generate interesting hypotheses, but they can't substitute for direct evidence and rigorous testing. It also demonstrates the importance of maintaining scientific skepticism, while remaining open to unexpected possibilities. Dismissing questions without investigation is as unscientific as accepting claims without evidence. The interdisciplinary nature of the investigation, combining archaeology, geology, climatology, linguistics, and astronomy, shows how complex historical questions often require expertise from multiple fields. No single discipline has all the tools needed to address questions about ancient civilizations and cultural development. One of the most fascinating aspects of this investigation has been how it connects different fields of study. What other historical mysteries do you think would benefit from interdisciplinary approaches? Lost civilizations, ancient technologies, cultural transmissions. The role of citizen science and amateur research has also been significant in raising and pursuing these questions. While professional academics have generally been skeptical of Atlantis claims, amateur researchers have kept the questions alive and contributed valuable observations and analyses. This suggests a need for better communication and collaboration between professional and amateur researchers. Academic skepticism serves an important quality control function, but it shouldn't prevent investigation of legitimate questions raised by professionals. The technological advances that have made this investigation possible, satellite imagery, computer modeling, ancient DNA analysis, precision dating methods, continue to evolve rapidly. Techniques that weren't available even a few years ago are opening new possibilities for investigating ancient history and prehistory. Future technological developments, better remote sensing capabilities, improved ancient DNA extraction, more sophisticated climate modeling, artificial intelligence for pattern recognition will provide even more powerful tools for investigating these questions. The global nature of the investigation is also significant. Questions about Atlantis, Egyptian civilization, and climate change during the Younger Dryas connect evidence from multiple continents and require international collaboration. How do you think global collaboration in archaeology and ancient history has changed our understanding of human development? Are there advantages to international research teams working on these questions? The public interest in these questions demonstrates the continuing relevance of ancient history to contemporary concerns. Questions about civilizational collapse, knowledge preservation, and cultural resilience have obvious connections to current environmental and social challenges. Whether or not Atlantis existed, the questions it raises about how societies develop, decline, and recover from catastrophe are highly relevant to understanding our own civilization's challenges and possibilities. The investigation also demonstrates the complex relationship between scientific inquiry and popular culture. The Atlantis question has been heavily influenced by popular media, alternative history claims, and nationalist mythologies, which have made scientific investigation more difficult. But popular interest also provides motivation and funding for research that might not otherwise happen. The challenge is to channel that interest toward rigorous scientific investigation rather than sensationalized speculation. Looking forward, I think the most promising avenues for research are, first, systematic archaeological investigation of potentially relevant sites, like the Richet structure. Second, improved paleoclimatic reconstruction of the end Pleistocene period. Third, comprehensive genetic analysis of early populations in relevant regions. And fourth, better integration of archaeological and geological evidence. What aspects of this investigation do you think are most likely to produce significant discoveries in the next decade? Archaeological excavation, climate science, genetic analysis, new satellite technology. Tell me what you think will crack this case wide open. The importance of maintaining scientific standards cannot be overstated. Whatever research is conducted on these questions needs to meet the same methodological standards applied to other archaeological and historical investigations. Peer review, independent replication, and transparent publication of methods and data are essential. The stakes are high because extraordinary claims about human history affect how we understand ourselves and our capabilities. If evidence emerges for sophisticated prehistoric civilizations, it would fundamentally change our understanding of human cultural development. If such evidence doesn't emerge, it's important to be honest about that outcome as well. Ultimately, the Atlantis investigation serves as a case study in how to approach controversial historical questions scientifically. It demonstrates the importance of following evidence rather than belief, of testing hypotheses rather than defending them, and of remaining open to unexpected discoveries while maintaining appropriate skepticism. The questions we've explored tonight about lost civilizations, cultural transmission, catastrophic change, and human resilience will continue to fascinate researchers and the public, regardless of whether Atlantis itself proves to be fact or fiction. And perhaps that's the most important point. The questions are more valuable than the answers. The process of investigation, the development of new research methods, the interdisciplinary collaboration, and the public engagement with scientific inquiry, these are the real benefits of taking controversial historical questions seriously. So there we have it, 2 hours diving deep into one of history's greatest mysteries. We've examined the evidence, weighed the arguments, and explored the implications. We've traveled from Plato's dialogues to the Sahara Desert, from ancient Egypt to cosmic catastrophes, from geological formations to genetic analysis. Let's see how your thinking has changed. Remember that poll from the beginning about whether the Richet structure could be Atlantis. Here are the results from before we started our investigation. And here's what you're saying now, after 2 hours of evidence. Fascinating how minds can change when you actually examine the data. What have we learned? First, that extraordinary claims require extraordinary evidence, but that doesn't mean we should dismiss them without investigation. The correlations between the Richet structure and Plato's description are too striking to ignore, even if they don't constitute proof. Second, that human cultural development is more complex and potentially more dramatic than our standard models suggest. Whether or not Atlantis existed, the rapid rise of Egyptian civilization demonstrates remarkable human capacity for cultural achievement under the right conditions. Third, that interdisciplinary investigation can reveal connections and possibilities that single-discipline approaches might miss. The combination of archaeology, geology, climatology, and astronomy has opened up avenues of inquiry that wouldn't be visible from any single perspective. Fourth, that technology continues to provide new tools for investigating ancient questions. Satellite imagery, ancient DNA analysis, computer climate modeling, and precision dating methods have made it possible to examine these questions with unprecedented rigor. I want to thank everyone who participated in the polls, left comments, and engaged with the evidence throughout this investigation. Your questions and observations have made this a better and more comprehensive exploration. Keep the discussion going in the comments. But perhaps most importantly, we've learned that the journey of investigation is as valuable as the destination. The questions we've explored about human cultural capacity, about knowledge preservation through catastrophic change, about the relationship between myth and history, these are fundamentally important questions, regardless of whether they lead us to Atlantis. The methodology we've applied, examining multiple lines of evidence, considering alternative explanations, maintaining scientific skepticism while remaining open to possibilities, this is how we should approach any controversial historical claim. We've also seen the importance of intellectual honesty. Where the evidence is strong, we should follow it boldly. Where it's weak or ambiguous, we should acknowledge those limitations rather than overselling our case. The Atlantis question remains open. We have tantalizing possibilities, but not definitive answers. That's frustrating for those who want certainty. But it's also exciting for those who appreciate that history still has surprises to offer. If you've enjoyed this deep dive into ancient mysteries, make sure you're subscribed with notifications on. We've got more investigations planned that will challenge conventional thinking about ancient history, lost civilizations, and human cultural development. Coming up in our next episodes, we'll be exploring other controversial connections in ancient history. Did the builders of Göbekli Tepe influence the development of Mesopotamian civilization? Was there a global maritime civilization during the last ice age? How do we explain the sophisticated astronomical knowledge found in cultures worldwide? We'll also be following up on new research developments related to the topics we've covered tonight. The Younger Dryas impact hypothesis continues to generate new evidence and controversy. Archaeological investigations in North Africa are revealing unexpected complexity in prehistoric societies. Ancient DNA research is revolutionizing our understanding of population movements and cultural exchange. But most importantly, we'll continue to apply rigorous scientific methodology to these fascinating questions. We won't cherry-pick evidence that supports predetermined conclusions. We won't dismiss possibilities simply because they challenge conventional thinking. And we won't accept claims without subjecting them to critical analysis. Join our community of investigators. Share this video with friends who enjoy intellectual challenges. Start discussions in your own networks about the questions we've raised. The more minds we have working on these problems, the more likely we are to find answers. The ancient world holds many secrets, and human history is far from completely understood. Every year brings new discoveries that change our understanding of what ancient peoples were capable of achieving. Some of these discoveries confirm our existing models. Others challenge them in fundamental ways. The Atlantis question sits at the intersection of known and unknown, of evidence and speculation, of scientific investigation and human imagination. Whether it leads us to a lost civilization, or simply to better understanding of human cultural development, the journey of investigation is worthwhile. Remember that the greatest discoveries in archaeology and history have often come from questioning conventional wisdom and following evidence where it leads, even when it leads to uncomfortable or surprising conclusions. The pyramids were once thought impossible for ancient peoples to build. Troy was considered mythological until Heinrich Schliemann found it. The sophistication of ancient astronomical knowledge was underestimated until computers allowed us to model ancient sky positions. As we wrap up, I want you to think about how this investigation has changed your perspective. Are you more open to questioning conventional historical narratives? More skeptical of extraordinary claims? More appreciative of the complexity of historical investigation? Share your thoughts in the comments. The tools and methods we've explored tonight: satellite archaeology, ancient DNA analysis, paleoclimate modeling, interdisciplinary collaboration, these represent the cutting edge of historical investigation. They're giving us unprecedented power to investigate questions that previous generations could only speculate about. But with that power comes responsibility. We need to use these tools rigorously and honestly, following evidence rather than wishful thinking, testing hypotheses rather than defending predetermined conclusions. The Atlantis investigation demonstrates both the potential and the challenges of this approach. We can examine correlations and possibilities with unprecedented precision, but we still need direct evidence to reach definitive conclusions. As we continue to develop more sophisticated research methods and discover new archaeological sites, the questions we've explored tonight will remain relevant. Whether future research confirms or refutes the Atlantis hypothesis, the investigation itself advances our understanding of human history and cultural development. Thank you for joining me on this intellectual journey. Your engagement, questions, and critical thinking have made this investigation richer and more comprehensive. Keep questioning, keep investigating, and keep pushing the boundaries of what we think we know about the past. The ancient world still has secrets to reveal, and human history is still being written. Every new discovery, every refined dating technique, every innovative research method brings us closer to understanding who we are and where we came from. Whether Atlantis was real or mythical, whether the Richet structure is a lost city or a natural wonder, whether Egyptian civilization developed independently or inherited ancient knowledge, these questions will continue to fascinate and challenge us. And that's exactly as it should be. The best historical questions are those that push us to examine our assumptions, develop new research methods, and think more deeply about human capability and cultural development.